Hey everyone, and welcome. So picture this. You're in a place where there are no cell towers, no Wi-Fi, nothing. Maybe a disaster zone or a super remote location. How on earth do your devices talk to each other? Well, today we're diving into the really cool world of ad hoc networks. These are networks that literally build themselves on the fly, no central command needed.
So that brings us to the big question, right? How do these devices actually connect and find each other? I mean, without a router to direct all the traffic, how does a message get from point A all the way to point B? That's the puzzle we're going to solve today. All right, here's how we're going to break it all down. First, we'll talk about the challenge of routing without a router. Then we'll look at two totally different solutions, DSVV, the proactive one, and DSR, the reactive one. And finally, we'll put them side by side to see how they stack up.
Okay, let's jump right into our first section, routing without a router. This is super important because it sets the stage for why we can't just use the regular networking rules we're all used to.
Think about your home Wi-Fi. Everything connects to that one central box, right? Well, in an ad hoc network, that box just doesn't exist. The whole network's shape, what we call its topology, is constantly shifting as devices move around. This means every single device, every phone or laptop, has to be smart enough to act like a router, passing messages along for its neighbors.
So, how do we tackle this? Well, our first method is a protocol called DSDV, and I like to think of it as the always ready planner. This guy believes in being prepared for absolutely anything at any time. DSDV stands for Destination Sequenced Distance Vector, and the keyword here is proactive. What that means is that every single device in the network is constantly maintaining a complete map of, well, the entire network. It always knows the best and shortest path to every other device.
So, how does it keep this map up to date? It's actually built on some classic old-school routing ideas, but it has a clever twist to handle all that movement. To keep everything fresh, each device periodically shouts out its entire address book, its routing table, to all its neighbors. It's a pretty chatty approach, for sure, but it means everyone is always on the same page. Now, let's look at a completely different way of thinking. This is the DSR protocol, which I call the on-demand navigator. This one doesn't do any planning ahead. It only figures out a route when you actually ask for one. DSR, or dynamic source routing, is what we call a reactive protocol. So unlike DSTV, which is constantly gossiping and updating its maps, DSR literally does nothing until one device needs to send a message. Only then does it wake up and go, okay, I need to find a path to get this message there. Here's the cool part. When a device needs a path, it just broadcasts a route request message. As this message hops from device to device, each one adds its own address to it, like signing a guest book. By the time it reaches the destination, that packet contains the exact path it took to get there. The destination just sends that path back. And what's really key is that only the original sender needs to know the full path. All the devices in the middle don't have to keep any maps at all. You can really think of DSR as a simple two-step dance. First, there's route discovery. That's the whole process of sending out the request to find a path. Then there's route maintenance, because, these networks are always changing and connections can break. So this part is all about noticing when a path is broken so you can find a new one. Okay, it's time for the main event. Let's put these two philosophies, the planner versus the navigator, head to head to really see the pros and cons of each. This is the showdown, proactive versus reactive. So here's the fundamental trade-off. With DSTV, the proactive planner, you're always ready. The routes are right there, so there's very little delay or latency when you send data. But the cost is all that constant chatter, which eats up a lot of bandwidth. On the other hand, DSR, the reactive navigator, is way more efficient. It doesn't send all those constant updates. The trade-off, you have to wait a little bit at the start for it to find a path before your data can actually go anywhere. And really, it all just boils down to this simple idea. The fundamental difference is planning ahead versus reacting on the spot. DSDV spends energy up front to always be ready, while DSR saves its energy until the last possible second and just accepts a small delay as the price. And that leaves us with one final big question. Which one is better? The meticulous planner who knows every single road, or the on-demand navigator that just finds a path when you need it? The truth is, there's no single best answer. It completely depends on what the network needs. How much are the devices moving? How much data are you sending? Is speed more important, or is saving bandwidth the priority? It's a classic engineering trade-off, and the right choice is all about the situation.